Hello and welcome to PCS Electronics. Today, due to the popularity of the one video I posted, the Xantrex Freedom 458, I'm going to be taking another look at this because another one came in for repair. This one, what I wanted to show you here, if you have one that looks like this, they come in two different manufacturers' names, even though they're the exact same thing. So you have one that looks like this. This one is the Heart Interface Freedom Combi, and it is identical to what I have here on the test bench, which is the Xantrex Freedom 458. So no matter what it says in the front, it is exactly the same thing on the inside. So today what we're going to do is, this one came in for repair, and like sometimes that happens, that I couldn't find anything wrong with it. So we do get that from time to time. People send something to us, they think it has a problem, and we find out that it doesn't have a problem. So I thought this would be a good one to use just to show you how these things work, since there seems to be a lot of interest in these. These are very popular. We get a lot of motorhomes in with these units. Generally, they're very reliable. They're pretty easy to work on. So, overall, good unit. It's an inverter charger, 2,000 watt. One of the questions I had is how to turn this thing on and off. So let's review that real quick, because there's actually 3 ways to turn this thing on and off. So first, let's turn the power on the bench. This unit runs at 12 volts, and we got 12 volts up. We'll go ahead and look at the display, and you'll see the LEDs come on. The LEDs will stay on for a short time, then they'll go out, which is just a power save feature. It doesn't mean it's off. It's just they go out to save power. So whether you hit the invert button now or after they go out, it'll start up. So we'll go ahead and start it. And then we have our step waveform. Have our indications. So if you have the remote panel like this is the way you turn it on and off. Another way you can turn this on and off is you have these buttons on the front. And I'll have to issue a correction, because I told somebody that you have to push and hold this button, which you do, to turn it on. So to turn it on, you have to push and hold the button, and it'll come on. But to turn it off, you simply give it a jab like that, and it'll shut off. So it's push and hold to turn it on, and then just a quick push to turn it off. So that's the second way. Now the third way, if you don't have a remote, so I'm going to unplug the remote here. There's this little port here. Normally there's a little flap over it. It's called auxiliary switch. And this is if you don't have the remote but you want to set up a remote switch. You can wire this up just to a switch and run that into your motorhome where you can get to it easily. And you simply just close this. There's a little delay, and then the unit will turn on. So that's a third way that you can switch this unit on and off. Turn it off, then you see it goes out. So 3 ways to turn this unit on and off. Alright, so let's get it inverting again here. Oh, well, I forgot to plug the remote in. It helps if you plug it in. Okay, so there's the remote port. Next to that is the battery temperature sensor. And during testing, I don't have to have that plugged in. I'll plug it in just to test that feature. What that does is there'll be a sensor located in your battery compartment. It'll look possibly like this. Or maybe it'll be stuck on the side of the batteries and it'll look like that. These are thermocouples that report the temperature value to the main unit, and it will alter the charge cycle to help to prevent overcharging the batteries on hot days and undercharging the batteries on cold days. So it's just an optional feature. You don't have to have it to run it, but it helps to increase the life of your batteries. Another note is, you notice this one, this is just like you stick it on the side of the battery, and this one you actually have to bolt to something. So what you need to know about this is that this metal tab doesn't electrically connect to anything. It's just a holder. The temperature gets transferred through this metal to the body, and then inside here the temperature sensor picks up that temperature. So I can bolt this to the negative, I can bolt it to the positive, doesn't matter. I can bolt it just somewhere in the battery compartment to pick up the temperature. The reason they do this, the idea is that if I bolt this right to the terminal on the battery, the temperature in the battery is going to come out to the terminals, and it's going to be a better reading of the actual battery temperature. But here's something you have to consider. When you locate this on the battery, if you want to use it on the terminal, you got to be careful, because if you have the main feed wire, let's say you've got your main positive feed wire coming in, and that wire's carrying 100, 200 amps when your inverter's running a good load, this terminal's going to get hot. And that's normal. When you have that much current running through a wire, it gets warm. So it really isn't an actual reflection of the overall temperature of the battery itself. And what can happen is it can give you a false over-temp reading. So what's better is, especially if you have a series parallel combination pack like this, is that instead of putting it on the one on the end here where you have a feed out cable, put it in the middle here where your two batteries join together. And then this won't get as hot, because this with a series parallel combination like I've got here with 4 batteries, this is going to be half the current as the feed-in wires. So this would be a better place to bolt it. If you continue to have problems with it giving you an over temp because of your terminals, well, one thing you got to be sure is that your terminal's in good shape. I mean, if you have a loose connection, corroded connection, or if you have a bad crimp, that could be causing the heat, and you need to look into that. But if everything is good, and you can't seem to find one that works well for you, I mean, these will work. Just put them in the vicinity where the batteries are. It's good enough. It really, if it's 100 degrees outside, this temperature sensor will know that, and it will throttle back the charger so you don't boil your batteries. So that's the whole idea. So that's something to know about battery temperature sensors. Okay, let's discuss another feature of this Xantrex inverter. This power share button on your remote, if you have the remote, what this does is it will reduce the amount of current that the battery charger draws to reduce the overall current that you're pulling on your shore power connection. And I'll show you how that works. So if you have, like right now it's set to 50, and you would think, oh good, I want the highest setting, right? Get the most current. Well, that's not how this works. If you are plugged into a 50 and you want to give your battery charger the most current possible, then yeah, you could leave that set at 50. And then if you're plugged into a shore power of 30 amp, would be good to reduce that to no more than the 30 amp. But let me tell you why you may want to set it even lower. Right now, we're inverting. I've got a 1,000 watt load set. Well, no, I don't. Here, another 500 watts here. Okay. Now we have 1,000 watts load, and we're pulling 83 amps out of the batteries. Right now, since we're running on inverter, we have no current coming from our shore power. I'm going to go ahead and switch on the shore power, and the inverter will switch to drive that shore power straight into my load. So my load is drawing 7.17 amps into my 1,000 watts. Now the battery charger is going to ramp up since you have shore power. You see it starting to come up. And as that comes up, now you're pulling more and more power from your shore power. And look what happens. We're up at 22 amps So if you're on a 30 amp shore power, you've just used up almost all your power pumping 100 amps into your batteries. If you're going to be there all day plugged into your shore power, you really don't need to pump 100 amps into your batteries and take 20 amps off your shore power. And then, you turn on your air conditioning and you pop your breaker. So what you do is you come over here and you lower this down, say 15, and what that will do, see how far that dropped? It does throttle back your charger. Your charger's only pumping 45 amps instead of the 100 amps in your batteries. But look at how much current I saved here. Now I'm only pulling 13 amps from the shore power instead of 22 amps. And that gives me more room to turn more things on if I need to. And, if you're plugged in all day long, there's plenty of time at 45 amps to get those batteries charged up. So that's what this feature does. It's a way to help prevent blowing that breaker out there on the pole. So if you're not in a hurry to charge your batteries, just run it down to whatever works best for you. So that's your power share feature. Okay, the next thing would be, alright, let's get this thing inverting. We got remote plugged in. And there it goes. Okay, so now it's inverting. 11.9 volts in, 122 volts out. Switch on some load here. Okay, we've got, looks like 1,000 watts switched on, so we've got 90 amps coming in. Okay, good enough for the demonstration. So that's the invert function, simple enough. Now for charging, the way these things charge is you bring in AC. You have one AC input, and there is a breaker on the front of this unit. Well, let's explain all the breakers. You have two output breakers because this unit has two outputs. So this is just your protection for your output wires, and there's two circuits, and those two circuits go off to two different places in your motorhome. You might have your microwave on one and your TV on the other, and if you turn those off, then your output's going to go out. But you normally just leave those on. So that's your output side for the inverter. Now for the input side, you have this little push button breaker right here. This is a 25 amp, kind of hidden behind the wire here, but if you have a problem with the battery charger where it starts drawing too much current, then this button will pop out. So that's something to know if your battery charger stops working, or if you just stop getting AC out of the unit for some reason. You got to check this button and make sure it's pushed in. So to get the battery charger started, I'm going to bring AC in. Okay, so we switched over to charge, and on your display you'll see the AC in light come on. It tells me my battery's in a low state, and then the charger will start ramping up. You'll see the current coming up. And so now we're charging the batteries, and the AC that's coming into the unit is now being passed directly through the unit, and that's why you have a sine wave coming out, because now you have utility power powering your loads, and then that power is also coming into the battery charger section of the inverter and charging the batteries. So that's the charge function. Something interesting about the charge function on this is that it uses a triac. This third red wire here coming out of the transformer goes into a triac and actually regulates the amount of power going into the batteries. And you can see that here on my scope, the actual signal as a result of the triac action. Let's get my sync Sync level's a little too high here. Let's bring this down. There we go. Okay. So you see there's been a bite taken out of the sine wave here. Normally the sine wave would run up and over and then down. And you can see there's a section missing. Well, that's where the triac is shut off to limit the amount of power going into the batteries. And the best way to see this is if I shut the battery charger off. So now it's you're just seeing the normal step wave coming out of the inverter. When I switch the battery charger on, you'll see how that triac controls the power in the sine wave, because it'll ramp up and you'll see it come up slowly. Okay, so there it's coming up. And that coincides with the ramp up of the current going into the batteries. So let's take a tour of the inside and you'll see how all that comes together. This section here in the back, that's your heat sinks, all your transistors tied into that for the invert function. And then of course filter capacitors, large transformer. Transformer steps the 12 volts that's being switched back and forth into the primary of the transformer. That's these big heavy plate-like wires that go into the input side of the transformer, and then the output side is your standard output-looking wires from the transformer, your output AC, which then go into an AC board, relays and current sensors and things that's hidden down in here, and then out to your output. So on these units, the 12 volts comes in. It gets switched back and forth by the inverter into the primary, comes out the secondary into your AC board, which is your output relays, switch things on and off, and then it comes out the output. Now when you charge, the AC voltage comes in on your two AC wires and produces a lower AC coming out of this, what was the primary now becomes a secondary, and that goes actually backwards through the inverter and through the body diodes of the FETs, gets rectified and out to the battery as DC. And the amount of energy that's coming out is controlled by the triac on this red wire, by the signal that you see on the scope. And the width of this gap that's being put into the sine wave is controlled by the microprocessor on the control board. So if you can actually hook a scope in here and you can see the pulse width modulation coming out of that processor going into the triac, and that's how it controls the charging. So fairly simple, elegant way that this thing inverts and charges. Like I said, these are pretty good units, normally very reliable. Let's go ahead and get this thing shut off, and I'll give you a view of the boards underneath the control board. So we'll shut the charger off, shut the inverter off, we'll kill the power. And I get my scope probe out of the way here. Okay, so to get this board off, you actually have to pull this connector out. You've got some screws you got to take out. Take off the remote cable. You got 3 screws, a cable, and this is your temperature sensor cable and your fan. And this board, you just got to pull it straight up. Maybe. There we go. And out. Alright. Insulator under there. So underneath the control board, this is your triac that controls your charging. And then down below there's relays and current sensor transformers. Your output circuit breakers. So that's called the AC board. So you have your AC board, your inverter board, and your control board. Okay, another thing I want to point out on the Xantrex Freedom 458, if you are so inclined and have some experience working with electronic devices and you want to try and see what's wrong on your own, you can take the top of the unit off, and there are 2 fuses in this unit. Some of them only have 1, and they're located, one here on the inverter board and one here right there. Kind of hard to see. One there on the power board, the AC board. So some of them have just 1, some of them have the 2 fuses, and so those are something you can check if the inverter stops working. But if you can't fix it yourself, you can send it to us and we'll be happy to get it up and running for you. So that's the tour of the Xantrex Freedom 458, also known as the Heart Interface Freedom Combi. I hope this answers some questions for you, and like I said, these units are pretty widespread in RVs, and normally very reliable. This one actually came in without any problems at all, so I'm not sure what was going on there. But we'll go ahead and do a test on it and send it back to the owner. So again, thanks for watching PCS Electronics, and we'll see you next time.